Hi, in this video I'll be covering how to provision and digit infra, which is nothing but creating a Kubernetes cluster and a database for our digit services, which is containerized, right? So in this video specifically we'll be looking into how to create a Kubernetes cluster and the database on AWS using Terraform, right? So there are other means to create digit infra, like if it is on premises, so we use kubespray, kubeadmin. There are many ways to create, which we will see in the upcoming videos. But today we'll focus on the Terraform, right? Okay, so before you get started, so ensure that you have the Terraform installed. You can refer the Terraform website for installation instructions for your specific operating system. So I'll get started since I already have it installed. So let me see whichever. Let me show you the version. So I have this particular version, but there is a latest version available, but I don't want to change it right now because I don't know whether there are changes in the APIs and stuff like that, right? So okay, so before I tell you how we are provisioned in digit, how we are creating a Kubernetes cluster versus what is the generic way that if at all I need to run a um, Terraform script, or I want to create a resource on any particular cloud provider using Terraform, right? So you can always, find this website, which is on, I mean, in GitHub, you can, uh, you know, get the various samples and you can get the understanding documents. But so this is how typically, like let's say I want to create a cluster on a EKS, right? So you can refer here. So why I'm showing this, because we in eager we do it slightly different, which is not something different from others, but there is a we follow certain standards. So just to differentiate, I want to show you this, right? So you can, for every resource, right, so you can create a separate uh, TF file. So for example, like if I have to create a cluster, you know I need I need a EKS cluster, which is a resource in AWS, and then worker nodes, it's another resource in AWS. Then VPC is another resource in AWS, things like that, right? So you can keep individual files for your various resources that you would need to create a Kubernetes cluster. So now how we do it in eGov, right? So I want to create a cluster called COVID U80. So there's a U80 environment that I want to create for a specific purpose, right? So how did this folder come? You can always, basically you need to check out a infra ops repository from Git, and you need to get into the Terraform folder, and inside Terraform there are already existing you know Terraform clusters configuration folders, right? So you can pick, so since it is EKS, you can pick any environment which is already created on AWS. So for example, I have copied this, and this is how the folders look like, right? So I have copied and just renamed this as a COVID U80 right now. Okay, so let's look at what is there inside, right? So there is a folder called remote state. So let's understand what is remote state. So basically, when you run a Terraform, right? So it's basically you run it from your local machine, then Terraform understands, when you do a Terraform init, so it understands, what are you trying to say and what are the, plugins that I would need. So it, ensures that it downloads and initializes all those plugins so that it can talk to the respective cloud providers and the resources and stuff like that, right? So what happens, in between, something has gone wrong, right? So, or like, you want to replay, or like, you want to maintain some state, or like, you want to work in a collaboration that, you do certain things and other person can also work parallelly, things like that, right? So the main focus here is to maintain this state so that you should be able to, recover it or replay it or share it and things like that. So what exactly it does? So uh, it stores the state of your Terraform into the S3 bucket. So this is what we are doing here. So if you look at what is there inside a Terraform state, so we are having a file. So that says that okay, so I need a resource. My provider is AWS, and this is the region, and I need an S3 bucket to store the Terraform state and create a bucket called this, right? You can always parameterize it, but since this is not used anywhere, so it's okay to hardcode. So that's how it is. So I need S3 bucket and the Dynamo DB table to basically store the state of it, right? So let's see what happens. Um, okay, so now I am requesting Terraform to provision these two resources, right? How do I do it? So first get into the respective folder. So I am in the COVID UAT right now. So I need to get into the remote state folder, right? Okay. So as you can see, you have a main.tf where you have the definition for whatever the resources that you want, right? The first thing that you need to do is Terraform init, right? So what it does, so basically, we are saying, my provider is AWS, and I need S3 and DynamoDB table, and Terraform in turn checks with its own library that what are the necessary plugins required for it, right? So when you say Terraform init, so it just goes and checks, initializes the back end, and then provider plugin it sets up. So this is what comes up. So yeah, so these are the plugins that it has downloaded. As you can see, provider AWS plugin, it has automatically downloaded. Okay, so the next immediate step that you would do is Terraform plan. So what is plan? So whatever the resources that you're requesting, it will show a kind of like a preview, like these are the resources that I'm going to provision. So it'll talk, I mean, it's not the actual thing, but through the APIs, API versions, and whatever the plugin that it has downloaded, it tries to see, if there is a compatibility, and whatever the, details that you're providing, is it matching or not, right? So Terraform plan. Okay, here you go. So it says that, there are two resources to be provision, and here is the detail. So one, it says the S3 bucket, and another is the DynamoDB table, right? So whatever the names that you have mentioned, so it is going to appear here. So it is going to create a DynamoDB table with this name, right? And similarly S3 with this particular name. So this is just a preview, but it has not provisioned anything right now. Okay, so now you can do a apply. So these are the three basic commands that you need to execute: init, plan, and apply. Init will ensure all the plugins and everything is there to talk to the respective whatever the cloud provider, and the plan will tell you like whatever the resources that you're requesting for, is there a compatibility and stuff like that. And apply is the actual action, right? So I can say apply. So it will still ask you for a confirmation before it actually starts provisioning. Of course, yeah. So this is what I asked for, and it will do little more checks, and finally it is asking for the confirmation. Do you really want to do it? Yes. So this is the time it actually starts provisioning. Okay, so yes, so it has done it. Now you might get a question that like, how is it talking to the cloud provider? I actually missed a point that before you run the Terraform on AWS, you need to ensure you are having the right AWS credentials configured, right? So you can always use the AWS configure command, and basically you need to you know it'll ask you for a uh, confirmation of your access key and the secret key and the region and stuff like that. So this is how you configure. Since I have already configured, I'm canceling this. So this is how it authenticates. So it takes the credentials from your AWS profile, which is set currently. If you have multiple AWS profiles, you need to ensure that you are currently on a specific profile where you want to create the resources, right? Okay, so now it says that it is created, right? So in the Terraform state, and if you want to output, you can always mention after creating any resource what details that you want it to be preserved as a some output, right? In this case, we haven't mentioned anything because we know pretty much like what we are passing, right? Okay, so now we have created a S3 bucket just to retain the state of whatever the actions that we are doing using the Terraform. Okay, so the next thing is creating a Kubernetes cluster. This is the actual intent of intent, right? So here is the script. So what it says, let's look at it very closely. So it says that, okay, I'm going to use S3 bucket. Uh, this is basically, which is already created. This I'm going to use it for the state. And next is I need a network, right? So where is the network? So as you saw in the example that you can either mention the specific resources in a separate file, and you can call all of them, and but here what we do, we put everything in main.tf and we put it in a sequence so that you don't miss the sequence, and everything is so organized so that it is easy to maintain, right? So we are saying, okay, one by one, I need first a network, and then I need a database, then I need a EKS cluster. So I'm mentioning all this for EKS cluster worker nodes, and then I have a lot of stateful sets like ES master, ES data, ES master infra, likewise, right? All these stateful sets need a EBS volumes. So this is nothing but the storage, right? So here if you see, we are mentioning the module, right? So where is this folder? So if you can see inside the Terraform, there is a folder called module. So here is where we put, the various resources that we need. We need DB, we need Kubernetes, we need storage. And inside each, so we separate it out based on the cloud provider, like AWS, Azure, and stuff like that, right? So here, like I need a EKS cluster. That's what it says. Module, then get into the Kubernetes, then it's a AWS, and then get into this source. So here is where you have to look for creating a module called EKS cluster, right? So inside this, again, there is a main.tf. So it specifically focuses on, what is required for a EKS cluster, which is more or less this particular thing, but it is just that it is organized properly such that it is easy to maintain, right? So inside EKS main.tf, so you will find the policies required for it, and what is the VPC, what is the role that you want and stuff like that. So specific to you know the EKS cluster, right? So likewise, you will see all other modules, worker nodes. So again, like you would see inside workers, like the worker node. So this is specific to worker nodes. So what are the resources that Terraform has to provision for a worker node? So this is, you don't need to code everything from the scratch. You can always refer the Terraform examples and stuff like that, right? Okay, so now again getting back to, so these are all some of the resources that I'm requesting from Terraform to provision. So network DB, EKS cluster, and the worker nodes for the same, and the various volumes, right? And another thing you can see, there are certain things that shows as a parameter. So it is coming from the variable. So like this file can vary from cluster to cluster, right? Because like it can have a specific name, and this is like a passing parameter to the generic ones, right? You can decide like what is the seeded block that you want. Do you want to create it in multi-zone, single zone, Kubernetes version? What is the instant type? How many nodes that you want? And okay, okay. So these are some of the parameters that we are passing to this main.tf, right? And if you leave anything blank, like for example, like, I want to, mention certain values during the runtime, right? So how do you do it? You can always do like this. You can just put an empty thing. Then Terraform will actually, ask you for that detail to be mentioned when you click Terraform apply, right? Okay, so let's get started. Great. Okay, I'm inside the Terraform, I mean remote state. Let me get out of it. Okay, I'm in the main. I have main.tf output provider variables. So variables are where I have mentioned all the details. So let me initiate a. So what happens if I skip the, like Terraform init? Let's see what happens. So it is saying backend reinitialization is required. So ensure that you do a Terraform init, right? So that means we need to run Terraform init for it to ensure that it downloads the required plugins and makes the compatibility checks and stuff like that, right? As you can see, it looks for a plugin, then templates, and whatever the resources that we have requested. Yes, it says okay. So based on what you have mentioned, I see this is the AWS version, that plugin version that I want, and HTTP and template version and stuff like that, right? Okay, so now we'll do Terraform plan. So this will now tell you, like whatever the resources that you have requested for, it will actually list down for your confirmation. Are you sure these are the resources that you want, right? And if there are any compatibility issues or anything, that it will show. Okay, it says that AWS cluster and policy in this context explicitly written. Okay, that's fine. So but let's look at, like whatever the resources that we were. Okay, I wanted the you know, the EBS volumes for zookeeper, one, two, IAM policies for my worker nodes. Basically, for any EKS worker nodes, we need, three policies. So worker node, then registry, CNI, and yeah, the IAM and profile. And then yeah, this is auto scaling. I want to do auto scaling, so I want to add it to a auto scaling group, and I'm setting min and max as this. And later point in time, either you can run the same Terraform to change this min and max, or you can directly change there in your AWS. So this is for auto scaling purpose, right? Okay, so everything looks okay, and this is a VPC, and this is a serial block that I want, and this is a public subnet, and then I want two public subnet, and then two private subnets, and then security group for my nodes, and ingress, egress. So this is nothing but, whatever the resources that you see, it is talking to the respective modules, and then whatever is the ask, so that is what it is checking and showing here. Okay, all good. So now let's get to the apply. So yeah, so this is your, when you do a apply, it doesn't really do the real action. Still it will ask you whether you want to proceed or not. So okay, when I say yes, so this is when the actual action begins. Okay, so it started. So it started with the volumes. So the advantage of the Terraform, like when there are so many resources that you would need for a cluster, you want to standardize the sequence and you don't want to miss anything, right? So this is when you will standardize the template. So Terraform automatically takes care of these dependencies internally, like if I want to provision a EKS cluster. So what are the, the policies that I need? What are the VPCs, subnet groups, things like that. It takes care of all those sequencing and the dependencies automatically. So this is one of the advantages of, you know, using the Terraform. At the same time, you can standardize across the various cloud providers like AWS, Azure, and stuff like that. So this is going to take some time. Let me pass and come back when it is done. Meanwhile, let's check in the cloud whether the provisioning is happening or not. Okay, so we have requested for a S3 for the state. Yes, so it is created, and it is created by the Terraform, and we requested for a EC2. As you can see, the volumes are being provisioned, and the security groups are being created. Elastic IP we requested for. Okay, so yes, so we have asked for these, and it is being provisioned through Keeper. One more volume has to come up. So that's what is happening. Okay, so that's still taking time. Okay, so while it's complete, so let's quickly summarize. So how do you create a cluster using AWS, using Terraform on AWS, and with respect to eGov's context, right? So you need to check out the Infra-ops repo, and when you get into a Terraform folder, you would see many of the existing Terraform folders. So depending on if at all you want to create anything new, you can always choose any existing, and then you can change the values. So what are the values? So as I mentioned, like remote state is the first thing. So this is to maintain the remote state so that it retains the state. And then main.tf, here is where you will put all the various stuff that you want, and obviously you will link it to the modules. So if you want anything new, you would always go back to modules and add your resource here depending upon which cloud provider, and then you will always come here and you will say, okay, I need module X, and then go pick the source from this, and these are the values that I need to supply, and some of these values that I would pass it as a parameter, and all the parameters, I mean, you will capture it in a variable, I mean variables.tf, so that it is easy for all the changing things. You can maintain at one place and you keep changing things, right? Like the Kubernetes version and the instance type, number of nodes, and the name and stuff like that. And not only that, like you can still parameterize many of the stuff, like like the DB version, and what is the instance type that you want for DB. You can always, what is the name that you want. You can move all this to variables, and always you can pass it from there, right? So let's see. Yeah, you can see the database is created and it is available, and your EKS. Yes, the server is getting ready and the version is 1.9. It is still creating, and the volumes are created. Worker nodes are not yet created. We'll see if it is the auto scaling groups are created. Okay, it is yet to create. And security groups. Yes. So it has created security groups for DB separately, and then EKS, cluster, masters, nodes separately. Right. So this is how you create a digit infra using Terraform, which is there in our infra ops. And this is no different when it comes to different cloud providers like Azure and GCP. You can keep adding. Um, so for example, like you take this one, so it is using a Azure. So what will change? So from a provider to provider, so certain things would be changing, like you may have to pass different values, and you should change these the source to pick it from the right resource. So obviously the way the parameters will differ from a provider to provider. You need to ensure that you always refer and add them appropriately, otherwise Terraform will fail.
Okay, so the Terraform failed eventually. So the reason is it couldn't find another instance out of three in auto scaling group. So it timed out. So this is one of the advantages of Terraform. So if in case, like in a sequence of resources that you requested, if something fails, so you can actually you know re-trigger the Terraform apply. So it automatically identifies which is the resource that failed, and it automatically tries to delete that as well as try to recreate that. So this is what I've done. So once it failed, so I've again initiated. So it gave me a kind of summary that your auto scaling group is tainted, so it must be replaced, right? So and finally, yes. So when I agree, yes, go ahead and replace. So it is successful, right? Right. So with this, like we can conclude this digit infra setup using Terraform on AWS.